Hello, my name is 𝗵𝗲𝗂𝗍𝗂, Regional Sales Manager at Parker Lord. We are here today to talk about 𝗵𝗏𝗃 NX100, our new generation top coat adhesive. In the agenda for today, we have the new 𝗵𝗏𝗃 NX100 development concept, the new product technical presentation, commercial advantages, and next steps. To start with the 𝗵𝗏𝗃 development concept, so why Parker Lord is developing this new 𝗵𝗏𝗃 adhesive? So first, EHS sustainability focus, the EPA regulations in the US, we need to eliminate chlorinated solvents, our focus on clean tech, and to improve supply chain as part of our risk mitigation efforts. And of course, our continued focus on innovation. And with that said, I now hand over to Paul Wheeler to cover the technical presentation.
Thank you, Andreas, for the introduction. Let me introduce myself. My name is Paul Wheeler, and I'm a product development scientist at Parker Lord, and I am one of the lead inventors of this new product line. So let me introduce this to you and share some of the technical information. First, what I'd like to share is a high-level summary of the test results. When we run our tests, we typically use ASTM D429, that procedure. We look at method F and method B, just real brief, and I'll get into the more specifics on the following slides. Method F is a tensile configuration, and method B is a peel configuration. And for this specific test, we compared it to a 𝗵𝗏𝗃 first generation product, and we looked at the variety of conditions shown on the slide. So just to walk through those real briefly, we looked at primary bonding, which is the bonding that you would get just after molding and not being exposed to any environmental conditions. We looked at a couple of environmental conditions, including boiling water, where the parts are actually elongated at 20% and then immersed in boiling water. Then we also look at salt spray for 1,000 hours, and this is also a stressed test where the parts are stressed at 20%. That's in the tensile configuration. In the peel configuration, we just look at primary bonding and then bonding after 4 minutes of a pre-bake condition. Then we also looked at mold fouling. And I'll show you data on the subsequent slides to substantiate this chart, but the summary here is that the new product gives at least equivalent performance as the old product. We do have a bonus where the boiling water performance is better, and you'll see that on the data slides in a couple of minutes. First, let me review the test methods that we used. ASTM D429 method F is that tensile configuration. A picture of the part, or rather a cross-section, is shown on the right side of the slide. It's a circular configuration, and that is pulled apart by those metal studs on the outside and then the rubber cylinder on the inside. The method B peel test coupon is shown on the lower right hand of the slide. In that configuration, we coat a metal substrate with 1 square inch of adhesive, and then those are peeled at 20 inches per minute. Just some experimental details for the data that I'm going to show you on the next couple of slides. So we looked at a sulfur-cured natural rubber that is a semi-EV compound. For the substrate, we use zinc phosphate-coated steel. We used injection molding as our molding method, and these were all cured at 160 degrees C. These were applied by hand with an HVLP spray gun, and then for the thicknesses, we targeted what you would consider a standard thickness for a 𝗵𝗏𝗃 type adhesive. So we used a primer of, in this case, it was 𝗵𝗏𝗃 205, and we applied it to 5 to 7 microns of thickness, and then the adhesive is applied on top of the primer, and that's 18 to 20 microns thickness. And as in this particular experiment, we're comparing a, we'll say a large running 𝗵𝗏𝗃 first gen product to a 𝗵𝗏𝗃 NX100. This first slide shows the test results of the coupon. So these are peel tests, and as you can see, the performance is very much similar between the two products. So let me orient you to this chart briefly. On the left y-axis, we have failure mode, and that's from 0 to 100%. So everything has to add up to 100%, obviously. On the right y-axis, we have peel strength, and that's given in pounds per inch. And then on the left hand of the chart, we have primary bonding, and then on the right hand of the chart, we have pre-bake after 4 minutes. And as you can see, both products perform in a very similar way. This next slide shows the results of our buffer tests. So we have 3 environments that we looked at: primary, 24 hours of boiling water, and then salt spray at 1,000 hours of exposure. Again, these are stress tests, so these parts are actually under a tremendous amount of stress before they're put into these environments. And as you can see, the performance between the first gen product and the NX100 are more or less the same. There are some improvements with the NX100, particularly with boiling water. So you can see that the NX100 performed quite well under that condition. This chart summarizes the data that you would see on a typical technical data sheet. And our intent with this product was to really match the performance and the application characteristics of a first-gen product. So if you were to compare the data in this chart to a tech data sheet of a typical first-generation ChemLock adhesive, you'll see that they're very similar. The idea being that you can just drop this into your process and with minimal adjustments be applying the adhesive. The data that I showed you is on natural rubber, but we've tested this product on a variety of other types of rubbers, such as chloroprene, EPDM, NBR, SBR, and others. So it is a general purpose adhesive that can be used as many different types of elastomers. Thank you very much. And with that, I'm going to pass the presentation back over to Andreas to talk about commercial advantages and then wrap up the presentation. Thank you.
Thank you, Paul. And now I'm going to cover the commercial advantages and next steps. As key commercial advantages for the ChemLock and NX100, we have been identifying potential hard savings in the applications that we have in the market. Potential complexity reduction. The NX100 can be used on multiple applications. We have a strong global footprint and local-to-local strategy and improved global supply chain. As next steps, order your sample, reach out to your account manager or distributor, conduct the trials and qualification process, and explore our Parker Lord application engineering support. We have a team of experts to help you during this process. We appreciate your time here today, and in case you have any questions, we are available to help and support you right now. Thank you so much, and have a great day.